Hello again, it's Dr. Pixel, here to tell you a little bit about series and parallel circuits. We'll try to make it easy. Let's take a look at the two little circuits I have put together right here. These are little buzzer pieces, and we have two AA's. Okay, now first thing to do is just observe these two circuits and how they're put together. Notice how this one here is going from coming out of the battery, and the red wire attaches to the red wire of the first buzzer, but then the black attaches to the red, the black attaches to the red, and then the black of the last buzzer attaches to the black of the battery pack. This type of circuit is the pieces are organized in series, which means the energy from the batteries comes out, the red, through the first circuit, down to the next, down to the next, down to the next, in order. Like a series on Netflix, where you watch the first show, the second show, and then the third show, but not at the same time, right? Now over here, on this side, we have a circuit that's put together a little bit different. Notice, again, I have three buzzers, but in this case, all three of the red wires of the buzzers are attached to the red wire of the battery pack, and the black wire is attached to the black wire from the battery pack. Interesting, right? Now this case is more like a split screen, okay? So the energy comes out of the battery, splits three ways, goes up through the speakers, and goes back down to the battery, right? So the energy is split here, but doesn't go through and goes them through all at the same time. Rather in this one, it's more of in order, right? All right, so that's how they're put together very differently. And so you might think, does that change how they perform? And the answer is yes. Now, before I show you what it does, think about what you think it will do. Which buzzer will be louder? Will there be a difference in pitch? Let's find out. So first I'm going to close the switch that I have with this first battery pack, and we'll listen to the buzzers. Kind of weak, right? We can hear it, but it's not that strong. All right, let's compare that to the parallel circuit. I didn't call that, but this one's called the parallel circuit. Whoa, much louder. It's very easy to tell that the parallel circuit is much louder. So in series, as the current goes through these different pieces, in this one, the current is lower than in these ones. And there's math behind this that you can look up if you'd like. But the math says the current going through these is lower. Essentially, they're shared, while the current going through these, they each get their own individual current path, so it's not shared. So this is the louder circuit, okay? We can see this as well, as we add each one, the effect. So if I go and take this battery and attach it just to the first buzzer, have the switch on, it's pretty loud. But if I add a second, ooh, we heard a pitch change too. It went higher, got a little quieter. With the third one, got a little higher and a little quieter as we added each one. It's harder to show you that in the parallel one, but the parallel circuit actually has the same loudness of one individual speaker. So when I add new buzzers to the parallel circuit, it doesn't change the volume or the pitch. So it's the same loudness as one. You can also often see it drawn in an engineering drawing like this, okay? So we have a plus and a minus side of the battery, and a parallel circuit has the red sides of your piece, and this is how we demonstrate a resistor. And all of our components, lights, speakers, that we've talked about so far are all in the class of resistors, are drawn like this. We have the red sides connected to the red side of the battery, the black sides connected to the black side of the battery in a parallel circuit. And in a series circuit, we have the black side of the piece connected to the battery, but then it comes out the red, and the red connects to the black of the next piece, and then the red goes to the red side of the battery. Now in a parallel circuit, if one of the pieces is oriented the wrong way, or red and black's the wrong way, the rest of the pieces will work. But in a series circuit, if one of the pieces is oriented the wrong way, the circuit won't work. So that's a little lesson on how circuits perform when they're wired together in series versus in parallel.